let me see. Okay, so we put in that gob of data, and you're all still upset with me about it. I understand. I'm sure you'll be okay, though. So we're going to go to stat plot. We've got to make sure we turn on our scatter plot for our data. Make sure all the settings are there, the lists are right, correct graph type. Then from here, you can just hit zoom 9. And it should give you your scatter plot. Now, if your plot doesn't look like that, if you're only seeing, if you put in like an X value, if you accidentally type in an X value, that's tremendous. Or a Y value, that's tremendous. If you may make a mistake, it will throw your entire plot off. So if your plot doesn't look like that, go through your data. Like one kid had, instead of 23, they had 23, 23. And that put, because remember what this is doing is it's taking the lowest X, the highest X, the lowest Y, and the highest Y. And it's just drawing a box around it. That's all stat plot does. So it wants to get in all your data. If you have a data point that's an accident and it's way out to the right or way up off the screen, it's going to try and graph that, and it's not going to look right. So if you ever get a stat plot that you really see everything smushed up in the bottom and one little dot all the way up here, that's what's going on. Okay, yeah. All right, so that's what this should look like. That's about what your plot should look like, right? Okay, so if you had to, knowing what you know, not what the title of the lesson is, knowing what you know, would you opt, what kind of regression equation would you opt to do? Exponential y? It's kind of curvy. It's got a little bit of a curve to it, right? So we wouldn't want to do a linear plot, because that really would, no matter where I put it, that really wouldn't kind of do such a great job, right, Willa? Linear wouldn't fit all that well. I think I can get a plot or a line that's more usable. Remember, you're never going to get a perfect line, but you want the most usable possible. So we're going to have all these lines that are different shapes. We have to pick the best shape, basically, to fit. So linear's out. Now, exponential isn't all that great either, because you see how it's got a little bit of a sharp hook up here? Typically, we've got 3 equations now. Today's going to be the new one. We started off with a linear, which was a plus bx. Then we did exponential, which is a times b to the x. Today what we're going to talk about is power. Y is equal to a times x to the b. In your algebra classes, a typical example would be a quadratic, ax squared, or 2x squared, let's say.
Is it called a quadratic regression?
Okay.
Is it called a quadratic regression?
No, it's called a power regression. Power regression. So we've used exponentials. Now here's how you pick. Basically, we're going to look at some residuals, and we're going to talk about residuals. But basically, in certain situations, certain lines work better. Certain regressions work better. We've used exponentials when we've talked about population, growth and decay. Anytime we're kind of working with percents, we generally work with exponential regressions. Okay? This is a graph of gas mileage by weight. It's a ratio. It's an inverse relationship. As weight goes up, gas mileage comes down. So whenever you're looking at 2 quantities that are in a sort of proportional relationship with each other, you may want to go with a power regression. It may fit better. That's just a hint. It's sort of like, look at your two quantities, try that one first type of thing. It's not carved in stone. But typically speaking, if it's a ratio with 2 quantities, a power regression may work better for you. Okay? Now the way to get your power regression, it's all the way down. So you're going to go to stat. You're going to go to calculate. It's down way at the bottom. I think it's A. There it is, power regression. I'm going to hit enter on it. I'm going to use my L1 and my L2. But I don't want to store it in Y1. I want to store it in Y5 because I have 4 other things in there, if you saw before my Y equals sign. So I don't want to delete any of those. So I'm going to choose Y5 to store it in. That's a good skill to get, especially if you're on a test, you're going back and forth between a couple of equations. You don't want to erase one and do it all over again, save you time. William.
But I deleted Y5 to get the residuals next tab, Y2.
You can do Y2, that's fine. Whichever one you want. I just don't want to delete only my Y's. So I'm just going to go to alpha trace, and that's going to bring up all my Y's. And I'm just going to hit the number 5 for Y5. So now it's going to put my regression equation in Y5. I'm going to hit calculate. There's a lot of data, so it might take a second. It's not a computer, it's a calculator. When you see the screen flash, then it's done. There it is. So there's your R value. That's not too bad. Negative 0.95. So our equation now should be in Y5. So I'm going to go to Y equals, and there it is down there in Y5. I'm going to turn off my 0.5x squared so I don't have to look at it. Remember to turn off a graph, you just hover over the equal sign and hit enter, and that'll toggle it on and off. And also remember we're using the full power of our calculators because we saw with an exponential how much 1 or 2 decimal places could affect the results when that residual is double. Remember, it's like a 700 versus a 1400 residual. So I'm going to leave the full power of the calculator in there. Now when I go back and do my graph, I did zoom 9. It looks like a pretty decent fit. What do you guys think? Look good? All right. So now I've got a better fit, better than a linear. Probably better than an exponential, although I think for this data an exponential would fit pretty well as well. But it's ratio type data, so I'm going to stick with power regression. Okay, now let's take a look at the residuals. So if you still have, and you should have in your stat lists, residual, and they're calculated, you can plot those. So if you look at your residuals, scroll, go over to your list under residuals and try and find the smallest and the biggest residual. You won't be going very far. Just scroll down with your finger and just see if you can find the biggest and the smallest number on there. About. We're just estimating to make our window the right size. We just want to try, and we can always go back and mess with it a little bit more. Scroll down and try and get your largest and smallest residual because we want the height to match. Tell me what you get. All right, so we have our biggest we're going to say is about 5, and our smallest we said was about 1. Negative 0.4. So when we graph our residuals, we're going to go ahead and turn the plot on for the residuals. Okay, and now we're going to look back at the graph. So for our window, what we're going to say is, all right, let's go ahead. Oh, we have to hit zoom 9. Did that plot the residuals for us?
Yeah.
Didn't for me though. Am I okay? Oh, there's my residuals. Good. Mine missed it the first time. I don't know what I didn't hit. Okay, so there's our residuals, and they look pretty decent. A little bit more variation up front, but we're not looking at curved. When you look at your residuals and you see a curve, you probably ought to think about a different type of regression line. Okay? So let's take a look at the residuals a little closer. So I want to leave the x values as is, but I want to just zoom in right on the top and on the bottom of the residuals. So I'm going to go to my window and I'm going to manually use the information that I just told you to find. You said that the biggest was about 5 and the smallest was about 1, negative 1. So I'm going to set my window for my y minimum to be, I'm just going to go from negative 5 to positive 5. So this way I put that x-axis right in the middle of the screen, I can look at my residuals. So my y minimum, I'm going to make it negative 5. And for my y maximum, I'm going to make it positive 5. Now if I go back and look at the graph, that gives me sort of like a zoom in on my residuals. Because you're going to have to look a little tighter at your residuals to make a decision. So sometimes looking at them all the way zoomed out with your data, one second, Robert. Sometimes looking at them all the way zoomed out with your data doesn't help you. You want to kind of look at them a little bit closer. So even here, I'm looking at them, and I'm not seeing much curvature. It looks like they're pretty evenly spread on either side of the line. So I'm feeling pretty good about this. Even though it's a little thick up here, and it's a little better towards the end, they're still sort of evenly dispersed. Okay? Maddie?
Can we go back to your window?
Mm-hmm. Robert, what did you need?
Can you just turn off this graph for this stat plot for the data?
Mm-hmm. And then do zoom 9 again, and it'll graph the residuals. Yep, you could do that as well. Okay? I didn't touch the x value because I knew the x values matched up with the residuals and with the actual scatter plot. The only thing I cared about was the y. So now I can always go back and do zoom 9. And there's my graph with my residuals. Okay, and here comes my, I should have waited till my line was done. Okay, so, moral of the story, look at your scatter plot, try and pick an appropriate equation. It's difficult with exponential and regression. So to be able to, with exponential and power regression, so that's why I showed you the zoom in of the residuals. Because to choose between an exponential and a power can be very sort of subtle. So you need to look at it a little bit in bigger scale to be able to tell. So everybody cool with looking at your residuals full screen? Okay. Any other questions? Roddy? Robert, did you have a question? I'm sorry. Oh no, you asked, that was the one you asked. Go ahead.
I'm not zooming in.
Okay, remember what you have to do to zoom in. You had to do zoom and then window, I'm sorry, you have to do window, and then just make your y min -5. And your y max 5, and then just hit graph. Not zoom 9, because zoom 9 will put all the data in again. That's what you don't want it to do. Or like Robert said, you can turn off the scatter plot and then do zoom 9 around the residuals as well. Zoom 9 takes all the plots that are graphed and draws a box around them. So anytime you do that, whatever you have turned on is going to graph. Let me just turn this off.
Dr. Joseph?
All right, that's it, guys.
Dr. Joseph?